Hello everyone, welcome to UpSmart classes. This is your Reddy Prakash. So in the previous classes or in the previous chapters, we discussed more or less a major foundations of entire chemistry, starting from matter, atoms, molecules, reactions, acids, bases, salts. This set the base for a larger discussion of chemistry. Okay, a larger discussion of chemistry. All these chapters will be setting the basis. So these chapters are very important. So if you wanted to attend any competitive examination, any kind of competitive examination, this general science, especially biology, physics, chemistry, plays a major role. If you're watching this video and if you feel like this video is helpful, kindly go through the previous videos of chemistry so that you will get into a flow. You will cover all the topics of chemistry and you will be able to score a beautiful marks in chemistry and you will be able to qualify the examination whichever you are attempting. And me as a faculty or as a mentor or teacher, I wholeheartedly believe anybody who watches this video shall become officers in the future and make their parents and society proud of them. Okay, so let us now move into the next chapter, that is based on the periodic table, the evolution of periodic table, how the periodic table is arranged, what is the importance of arrangement, what are the advantages, what are the disadvantages. This is a very important topic or the chapter which will make sure why a particular atom, particular element, particular compound is formed and how are they arranged in periodic table. We have seen periodic table since our childhood, but we have never analyzed why a periodic table is set like that. All we have done is we have mugged up, we have by hearted. We have done the rote learning, like 1 to 10 these are the compounds, these are the rows, these are the columns, these are the periods, these are the groups. This is not periodic table. This is mug up of periodic table. You should understand periodic table, which we shall do now. Okay. So starting with why the classification was needed. Why the classification was needed. Why the classification of elements in a periodic table was needed? Because we can study them systematically. We can study a group of elements. Group of elements or the columns, and the periods or the rows. The horizontal ones are called the periods. The vertical ones are called as groups or the columns. We can study them systematically, why they are placed in particular group or particular period, and we can study that in a classified and systematic way. Second is group elements with similar properties will be grouped together, and elements with similar properties shall be in a similar group, so that there is limited confusion and a better research. Next, we can predict the properties of unknown elements. Unknown elements shall be placed separately and then they shall be grouped whenever the properties are classified properly. Okay, these are the need for classification, and when this need arose, there came the great men who classified all these elements, starting with Dobereiner's triad. So before discussing all this, I'll just give you a brief introduction to periodic table. So people who doesn't remember periodic table will get to know how a periodic table is arranged. They'll get a picture of periodic table. So after that we can discuss all these things. Okay, so let me take you to the periodic table. This is a modern periodic table. This is a modern periodic table. I hope you people can see this. If you're not able to see this, kindly keep your pixel, advance it to 1080p so that it will be very clear. Okay, now you see there are 7 periods, meaning the horizontal ones 1, 2, 3, 4, 5, 6, 7. These are the 7 periods. The horizontal rows. The horizontal rows are called as periods. There are 7 periods. Fine with that. And there are 18 groups. 1, 2, 3, 4 and so on. This is 13, 14, 15, 16, 17 and 18 periods. 18 groups. Group are the vertical columns. Groups are the vertical columns. Okay, understood with this? This can be a very important question. 7 periods, 18 groups. They can interchange it and ask as a question. This is one thing. Second thing, there is the extra one. Those are called as lanthanide and actinide series. Lanthanide and actinide series. Easy with this? So, you remember beyond these groups and columns, what is there is lanthanide and actinide series. Now, all these are separate groups. Group 1, Group 2, Group 3, Group 4. Understood? First one, the first group is called as alkali group. Alkali group. Group 1 is called as alkali group. The group 2 is called as alkaline earth metals. Alkaline earth metals. The second group is called as, I am giving you the major ones, the major groups. The second group is called as alkaline earth metals. These will have a valency of, the first group will have a valency of 1. It has a valency of 1 means the energy to react with the other element can be less means it will react easily. All that it has to do is it should lose the 1 valent electron, 1 remaining electron in the last shell. To lose 1 electron is easy, meaning it can bond with other element easily. If the valent electrons are more, say carbon is 4, meaning to bond carbon is slightly difficult. To bond carbon is slightly difficult because it should gain or lose 4 more electron, but only 1 electron means it can easily bond. The second one, second group, valent electrons are 2. Valent electrons are 2. Okay, this is alkaline group. Now, these are fluorine, bromine, iodine, astenine. These are, I told you in the previous class, what are these called as? Halo groups. Halo groups are 17th group. Last one is the inert group. Why inert? Why it is called as inert? Because you see, the valency of this is 1, valency of second group is 2, valency of the last 18th group is 0, meaning the electrons are properly in a stable stage. It need not react with other element to form a stable compound. It is already stable. The element itself is stable. It need not react with other elements to form a compound. That is why these are very less reactive. These are called as inert gases. Inert gases. Those will not react with other elements because it is already stable. It don't want to disturb its stability. Those are helium, neon, argon, krypton, xenon and Rn. Okay. So those are inert gases. The last second, the 17th group is called as halo group. This is a major introduction. All you have to know is, and I expect you to know is, there are 7 periods, horizontal rows. Those are 7 rows. Beyond that are lanthanide and actinide. That is one thing. And there are 18 groups. 18 groups. The valent electrons or the valency 1, 2 and so on. Last one is inert gases. Valent electrons, valency 0. Last second one is halo groups. Halo groups. Okay. This is something you should know. You should remember for a long time. Remembering this will set a base for this chapter. Now remember this. This chapter is over here. It is over. And one more thing. How do you think these are arranged? These are arranged because those have similar properties. Similar properties. Okay. And one more thing, these are arranged based on the atomic mass, atomic masses. Okay, atomic masses. Now I'll take you to the history. Now there is something called as triads. Triads. It was given by Dobereiner. This Dobereiner gave triads. Triad means three elements, group of three elements, and he gave a theory to explain why these three elements. Dobereiner gave the triads. What are Dobereiner triads? He told that group of three elements have similar properties. There are group of three elements, those have similar properties. They are lithium, sodium, potassium. Similarly, other two groups. Okay, group 1, group 2, group 3. He is telling that these three groups, the elements of each group has similar properties. These are alkali metals, valency with 1. The second group is alkaline earth metals with valency 2. The third one is halogen with valency 1. But sir, why only 3? We saw alkali metals. Wait, I'll show you again. But sir, these are alkali. These are alkali metals. These are alkaline earth metals. Why only 3, sir? Why only 3? You see here, there are 8. You see here, there are 7 groups. There are 7 elements in alkali earth metals. There are 8 members in alkali metals. And in halo groups, we have 5 metals. 5 elements. Why is considering only 2? This doubt you shouldn't get. So I am already creating a doubt. Okay? Why those 3 only, sir? Now we'll explain why those 3 only. Now what he says is group of 3 among those list of 8, 7 and 5 elements. These were originally the alkali metals have 8 elements. The alkaline earth metals has 7 elements in it. Halogen has 5 elements. But he is taking only 3 elements and making a triad. He is making a triad. And these 3 have similar properties he is telling. So what is it? The atomic mass of the middle element. This is the middle element. These are the middle elements. The atomic mass of the middle elements should be approximately the average of the other two. The atomic mass of sodium is average of lithium and potassium. That is, lithium plus potassium divided by 2 is approximately the atomic mass of sodium. So he grouped them according to atomic mass concept, and he is telling it has similar properties. But he could group only 3 triads could be formed. Out of the entire periodic table, you could find 3 triads. This was the limitation. So some people say this is only some coincidence. Had you found a large number of triads, say some 20, 30 triads, then we would have accepted. You are finding only 3 triads out of hundreds of elements. This was the limitation or the backlash or the criticism he faced. Fine. But remember these 3 triads. And it is based on atomic mass. The middle element mass is approx of first and the final element. Okay? Easy. Second one. There was someone called as Newland. What Newland? Newland's law of octaves. Octaves means octagon, 8. He grouped 8 elements. Newland gave octave law. Octave means 8 elements. Now we'll see what he is telling with the 8 elements. Why the 8? He is telling when elements are arranged in increasing order. When the 8 elements are arranged in increasing order of atomic mass. You see, lithium atomic mass is 3, 4, 5, so on. Okay. No, these are atomic numbers. Atomic mass will vary, but this is how the sequence will remain. This is how the sequence will remain. Increasing order of atomic mass, and every eighth element has properties similar to the first element. Every eighth element has properties similar to the first element. Which is the eighth element? Which is the first element? You have seen lithium ion battery, sodium battery. We have heard this, right? Lithium ion battery, sodium battery. Why not beryllium battery, boron battery, carbon battery, nitrogen battery, oxygen battery, fluorine battery? Why only lithium ion battery, sodium battery? Because this can something be related to Newland's octave rule. He says lithium ion is similar to nitrogen ion, or I mean sodium ion. The first element and the eighth element will have similar properties. When 8 elements are arranged in increasing order of mass, the eighth element will have properties similar to first element. That is why lithium is similar to sodium, and it will be used, both can be used as battery components. Battery components. Now understood the basis of lithium and sodium ion batteries? Yes, sir. So the observation, or it is similar to musical octave, but this is not much important. You can just remember musical octave enough. But limitations are, these are valid only up to calcium. Beyond calcium, these are not valid in a periodic table. Second thing, he assumed only 56 elements existed. While he did the research, he assumed in a periodic table only 56 elements are there. But now the number of elements increased. So that is a limitation today. Next, similar elements like iron, cobalt, nickel were placed separately. Why? He can place the similar elements in a sequence. Then if you place it, the first and second element might not always be placed in first and eighth element to prove the similarity. So these are separated to make it as first and eighth element. So what happens? This is a wrong step. This led to backlash towards the who gave this concept? Newland gave octave. Who gave this? Newland. So Newland faced the backlash due to separation of similar elements. Next is some dissimilar elements were grouped together to maintain the dissimilarity. Only 2 similar elements, the first and 8, were deliberately placed. You can remember like this, but I'm not criticizing the great person so much, but these are some limitations. This will not be asked. All that it will be asked is, they might ask who gave the law, something match the following at a maximum extent. That is what UPSC can go to according to my estimation, but this is to be on a safer side. Okay, next is Mendeleev's periodic table. Now what we use is the modern periodic table, but the precursor of modern periodic table was largely contributed by Mendeleev. Mendeleev gave this periodic table largely. Based on this, Moseley gave the modern periodic table. He was the original founder, Dmitry Mendeleev. Same, 7 periods, 8 columns, 63 known elements. Later, the number of elements increased. That became the modern periodic table. Fine. Mendeleev, what he did is, we'll understand his contributions now. And it was given by Dmitry Mendeleev. He assumed Mendeleev's periodic law. Again, this will repeat a number of times. The first person, Newland, he also assumed atomic mass. Before the triad principle also assumed atomic mass. Similar properties. Now what Dmitry says is, properties of elements का property are periodic functions of their atomic masses. That means properties are proportional to mass. Similar mass, similar properties. Something like that. Or variation in the properties, variation in the mass. That is the meaning of property of elements or periodic function of atomic masses. Same was assumed by the modern periodic table also. Next, the basis of classification is again increasing atomic masses. Increasing atomic masses. Next, similar chemical properties. Similar chemical properties in a groups. Increasing atomic masses, similar chemical properties. Easy. This was given by Mendeleev. Now we will understand the advantages and disadvantages of his classification. The advantages. Merits. He predicted few undiscovered elements. Before Mendeleev, there were elements, but they were not discovered. He discovered and named it as Eka boron, Eka aluminium, Eka silicon. Means similar to boron was there. Similar to boron, he found something. Aluminum was there. Similar to aluminum, he found something. Silicon was there. Similar to silicon, he found something. These are the 3 new elements found by Mendeleev. But the present naming, because it is not boron, it is not aluminum, it is not silicon, these are not exactly the same elements, and the new names was given to them. The Eka boron, the boron's similarity was given as scandium. Aluminum similar element became gallium. Silicon ka similar element became germanium. And the properties of them will be almost similar. But slight differentiation is there. That is why the new naming was given. Okay. Before Mendeleev, people assumed all these are similar in nature. They neglected the slight difference in the properties of boron and scandium, aluminum and gallium, silicon and germanium. Easy. This was one of the major advantage. Second thing, noble gases. Noble gases could be accommodated easily. In which group? Group 17 or 18. It is group 18, not 17. Okay, group 17 is called as halo group, halogen ka group. Group 17, chlorine, fluorine, bromine, iodine, astenine. So 18 group is noble group. Okay, inert gases group, noble gases. They won't react with other gases easily because their valency is 0. They are already stable. They don't want to disturb their stability. Noble gases was easily incorporated due to Mendeleev. Group 18 was later added without disturbing the table. Easy with this. But what were the disadvantages? What were the disadvantages that led to the formation of modern periodic table? Position of isotopes was not explained. Isotopes. Chlorine 37, chlorine 35 is some isotope. Why the position was not explained? Example 37 and 35 have different masses. Mass is different. Atomic number is same. But same chemical properties. Chemical properties are same. Position of this many kinds of isotopes like this was not included. Next, wrong order of atomic masses. He made some mistakes also. To agree, he made some mistakes also. He told that cobalt has atomic mass of 58.9. Nickel has atomic mass of 58.7. 58.7. If you see factually, cobalt should come after nickel in the periodic table. In the periodic table of Mendeleev. But he misplaced them. So that is a slight mistake. Be it only 0.2 difference. But that makes a lot of difference in the reactions and research. Wrong order of atomic mass. Third thing, position of hydrogen. He was uncertain where to place the hydrogen. Because hydrogen resembles alkali metals with a valency of 1. Hydrogen has a valency of 1. Alkali metals also has valency of 1. Example, lithium. Alkali metals has a valency of 1. That is group 1. Halogens exist as hydrogen. Halogen usually exists as hydrogen. Example, chlorine, F2, something like that. Here, H2. But hence no differentiation, no fixed position, because he was confused whether to place it in the group 1, that is alkali metals, or in the group 17, that is the halogens. He was confused. So no fixed position, because hydrogen showcased two similarities. Similarities with valency 1, that is alkali metals. Similarity with halogen. Okay. So I was confused. These were the advantages and disadvantages. Easy with this. So next one, modern periodic table. Modern periodic table, as I already said, it was given by Moseley. Moseley gave the modern periodic table. See, one more thing, when the names of inventors, scientists, discoveries come up, there will be 2 to 3 names. It will be bigger name. Don't remember the entire name. It will drain your energy. Remember the second name, which is most important. Moseley, Mendeleev, Lavoisier. Remember those names. That is more than enough. Okay. He based it on atomic number, not on atomic mass. This is the most important fact. Before him, everybody placed the periodic table based on the atomic mass. But this person placed it based on the atomic number 1, 2, 3, 4, 5, 6, 7. Oh my god. Hydrogen, here. Where is helium? 1, 2, 3, 4, 5, 6, 7, 8. He placed the elements based on the atomic number. Based on the atomic number. This is the most important. Don't forget this. Okay. Never forget atomic number, atomic mass. Next is modern periodic law. You think there is any change in modern periodic law? No. Properties of elements are periodic functions of atomic number. Everything is same except atomic number come up. Until then it was atomic mass. Mostly came up and it told it's not atomic mass, it is atomic number. Okay. Easy with this. There is a major difference, and all these things I explained. All these things I already explained. Okay. Next, this is something slightly confusing but very important for the examination. Very important for the examination. No skipping this slide. No skipping this slide. Wherever you are, keep this slide in 1080p. Take a screenshot of this. Daily morning you are waking up seeing this slide. Okay, this is most important slide of the chemistry. And the periodic table, characteristics or trends in the periodic table. If you see, the valence electron means not valency. Number of electrons present in the last shell are called as valence electron. If you see, lithium has how many valence electron? It is 1. What is the valency? Because it is easy to lose 1 electron, then to gain 7 electron, it will lose 1 electron. Valency is also 1. But what is the valency of carbon? It is 4. It will not lose, it will not gain. So valency is same. Beyond carbon, I'll show you. 1 second. Beyond carbon, what you get here? Nitrogen, right? Beyond carbon, you get the nitrogen with atomic number of 7. So it will have 5 electrons in the L shell. The number of electrons required for stability in the L shell is either 0 or 8. To get 3 electrons is easy for nitrogen, then to lose 5 electrons. So the valence of nitrogen is 3. Valence electron of nitrogen is 5. I am speaking about valence electrons now. So don't get confused between valency and valence electrons. See, valence electrons increases from 1 to 8. Valence electrons keep on increasing. Number of electrons will keep on increasing from 1 to 8. Next, valency first increases till 4. Till carbon, valency keeps on increasing. What are these 1, 2, 3, 4? These are the groups. Valency keeps on increasing till carbon. Beyond carbon, it will decrease. Nitrogen is 3, oxygen is 2, then it decreases. Okay. Then atomic size. You might feel like, sir, lower atomic number has lower atomic size. Higher atomic number will be having obviously higher atomic size. This is not the case at all. This is not the case at all. Atomic size will decrease. Atomic size will decrease because increased nuclear charge, increased charge pulls electrons closer. When the charge is more, when the charge is more, it will pull the electrons much closer. It will keep the, when it pulls more, what happens? It will make the element shrink, smaller. Which has more electron charge? Say this is lithium, this is beryllium, this is boron, this is carbon, nitrogen. This has valency of 1, valency of 2, valency of 3, valency of 4, valency of 3. Valency of 3 or valence electrons of 5. Valence electrons are 5. These are valence electrons. Valence electrons. See, valence electrons 1 to 5. Comparing from lithium, beryllium, boron, carbon, nitrogen. Valence electron increases. That means the charge, the net electrical charge on them will keep on increasing. When charge increases, the compaction also increases. When compaction increases, the atomic size will decrease. So the trend is atomic size will decrease, not increase with the periodic table. With the periodic table, atomic size will decrease. Next is metallic character. Metallic character decreases. Metallic character decreases. Non-metallic increases. Metallic character decreases. Initially, metals will be more. Initially, metals will be more. Going on, metals will decrease. That means metallic character will decrease. Non-metallic character will increase. Easy. Sodium is a metallic character, one of the highly reactive metallic character. Chlorine is non-metallic nature, highly reactive but non-metallic in nature. Next, chemical reactivity. Chemical reactivity, first it will decrease. First decreases, then increases, because most reactive metals on far left, most reactive non-metals on far right. Initially in the table we'll be having metals, right? At the end we'll be having non-metals. At the end we'll be having non-metals. Example, initially we'll be having metals like sodium. At the end we'll be having non-metals like chlorine. But sodium is also highly reactive. Chlorine is also highly reactive. Both are highly reactive. But going to the center from the both ends, the reactivity will decrease. The metallic nature will decrease. Non-metallic nature will increase. Okay. So what they tell is the chemical reactivity. First it will decrease until the center. Then it will increase until to the right end. That is the chemical reactivity sequence. Then it is ionization energy. Ionization energy. Ionization energy refers to energy needed to remove tightly bonded electrons. Energy needed to remove tightly bound electrons. See, I told you, to remove one electron is easy from lithium. To remove 2 electrons is slightly difficult. 3 electrons even more difficult. 4 electrons even more difficult. Okay. The amount of energy required to remove these electrons is called as ionization energy. Very simple. The amount of energy required to remove these electrons is called as ionization energy. So now you tell me, will ionization increase or decrease? Ionization increase or decrease means, will the amount of energy need to remove these electrons will increase or decrease? It will increase, right? So ionization will increase. That means more energy needed to remove tightly bound electrons from lithium to carbon. Next, electron affinity. Electron affinity means energy released upon adding electron releases. Energy released upon adding an electron increases. Now how much energy is released? How much energy is released? It is similar to this. Energy released upon adding an electron increases. It is similar to this. The definition is what energy is released upon adding an electron. That is called as electron affinity, and it will obviously increase. So I know that you are confused with this slide. But nobody has ever given a concise slide like this to make things simpler. Take any textbook, take NCERT, take any major researcher book, take PhD document, or take any institution ka notes. Show me a slide, show me a page which combines everything into one slide, because each one of them is a chapter. Each one of them is a chapter. Seriously, we can't study 8 to 7 chapters for one slide. I've combined this together, that is why it is simplifying. But once you understand, see it for 10 to 20 times, you'll get to know this. Believe me, this is the most easiest slide. Now revise this on a daily basis, automatically you will remember, yaar. But if you keep this like, okay, it is only one slide, I'll revise it just before examination, I'm pretty sure in 2 to 3 minutes you will forget, you will confuse. Remember about losing 2 marks. You lose 2.61 marks because your ego will tell you, I have read this, I have to mark this. At that point of time, your brain won't function. It will be telling, I have read this, but I don't remember this. But your ego, the heart will tell you to mark that. So the clash will lead to losing the extra 0.67 marks also. You will get the negative marks for the wrong marking. Don't make that happen. Revise it daily. I'm telling, keep it into 1080p. Take a screenshot of this. Wait, I'll clear so that your screenshot will be more easier. Take a screenshot of this by keeping into 1080p. Revise it daily. You will get a question from this. It is an easy slide. Next, key groups, which I already explained to you. This will be a recap. Group 1 are called as alkali metals. Group 1 is alkali metals. Group 2 is alkaline earth metals. Group 3 is halogen. Group 4 is noble gases. They might give these elements and they might tell you to match it. Okay, so be prepared. Why the alkali metals? Because valency is 1. These are highly reactive metals. I told you on the left corner we have metals. Right corner we have non-metals. But the left corner and right corner are highly reactive. So valency is 1, highly reactive. React violently with water to form bases. These ones react with water very aggressively and they'll form the base. Next is alkaline earth metals. Valency will be 2. These are reactive but lesser reactive than the first group, because I told you the reactivity will decrease until the center and then it will increase until the far right end. Okay. Next is halogens. Valency is 1, highly reactive. Non-metals form salt formers. They will make the salt. But the right end, as I told you, right end you will have inert gases. Right end you will have the noble gases, inert gases. Valency will be 0. Reactivity will be almost 0. They will not react at all. Just before the right end, you will have the 17th group, that is the halogen group. This will be highly reactive. But the 18th group, that is the last group, that will not react. That is called as inert group. Easy? Next, advantages of modern periodic table. It is based on atomic number. So it is much better. No confusion which is higher mass, which is lesser mass. So the properties and all will be properly set. Next is isotopes are placed together. Chlorine 37 and 35 has different masses. So Mendeleev was confused and he was not able to decode how to place these isotopes. Now since it is based on atomic number, not the atomic mass, these isotopes are always placed together. Okay. Next, correct position of cobalt and nickel. Due to variation in atomic mass, Mendeleev made a mistake. Now it is corrected. Next, explains periodicity of properties. That is, properties repeated after 2, 8, 18 and 32 elements. Properties are repeated after these numbers. Next, it makes chemistry easy and systematic. The first slide which studied. Helps predict properties. Helps predict the type of compounds formed. Act as a memory aid. These all are common, but this is important. The left hand sides are important. Next, the key terms which we studied already, which you know. How many periods are there? 7 periods. What are the periods? Horizontal rows. Horizontal rows are periods, 7 periods. What are groups? How many groups are there? 18 groups. Those are columns, vertical columns. First group is highly reactive. 17th group is also highly reactive. 18th group is not reactive. Those are inert group. First group are metals and last end groups are non-metals. Easy. Next, atomic number or number of protons or electrons are called as atomic number. Valence electron means number of electrons in the outermost shell. What is valency? Combining capacity of an atom. I told you how to calculate valency. Next is ionization energy. What is ionization energy? The amount of energy required to remove the outermost electron is called as ionization energy. We discussed that. Next is electron affinity. What is electron affinity? Energy released when the electron is added. When an electron is added, amount of energy will be released. That energy is called as electronic affinity. Next is metallic character. Tendency. Metallic character is tendency to lose electrons. Metals usually lose electrons. They will become charged. That is metallic character. Next is periodic law. What is periodic law? Property. Periodic law is periodically the properties repeat. Properties repeat periodically with increasing atomic number. Increasing atomic number. Easy, right? Easy slides, right? Now this chapter of periodic table is completed. The next chapter will be based on is matter pure or unders, how the matter is classified. This is a continuation of first chapter and a detailed classification of matter, how we study, and many things of regarding this matter and important questions are asked, so that we'll go into depth. Okay, so we have discussed everything about the periodic table. One question from periodic table is asked on an alternative year in various examinations, including CAPF Assistant Commandant examination. So make sure you read the chapter very well. So meeting up in the next class, we'll study about the chapter, about the matter chapter, the continuation of matter chapter. So this is me, Reddy Prakash. Thank you so much for listening to my class. If you feel this class is helpful, kindly share it with your friends and family. Subscribe to our channel so that any notification and important classes are not missed at all. And we'll also be covering various classes for various other examinations like NABARD, EPFO, RBI Grade B, various other examinations like SSC also. So stay connected, stay smart, and become more smart by getting connected with UpSmart. So thank you. All the best for your examination. Thank you.